Okay, this number 5, we have the lengths of segments PQ and PR are 8 inches and 5 inches respectively. And they make a 60-degree angle at angle P. So I'll call this 5. This is P. And this means this would have to be R. Call that 8. That's 60 degrees. That'd be Q. Okay, so was there a shortcut way? I shouldn't say that. There is a shortcut way to find the area of PQR. Does anybody remember it? Emily? No? Con? Tom? So we have, because it's a side angle side, we can go 1/2 5 times 8 times sine of 60. That will work. And what'd you get for that, Tom? 17.32. That'd be square inches. Perfect. Okay. So if you don't remember how to do that, you could have found the height, which we're going to have to find in a second anyways. So we could have found a height and then just use base times height divided by 2. Okay, B. Find the length of a projection of PQ onto PR. So what's a projection? Right. I think of a projection in terms of context as like a shadow. So if we had the sun directly above Q here, we would have a shadow of Q onto PR. So that's how I think of a projection, is just we have, if we drop an altitude from Q to PR, the projection would be the shadow length of PR or of PQ onto PR. So that length right there is your projection. Okay, now I actually did trig functions for this, but then I realized after I typed in the calculator that, oh, it's a whole number. So I want this length right here. How would we do that pretty simply? It's a 30, 60, 90 right triangle. So this right here is 60. So that means this angle up here is 30. So what would this length here be? 4. It has to be half. Half of the 8. Because it's across from the 30-degree angle. So that would be 4 inches. Okay, now we had to find the length of QR. So we need to find this length right here. QR length. How do we start to find that? We could use law of cosines. That'll work. So we could do law of cosines. And if we set that up, we would do square root. So QR equals square root 8 squared plus 5 squared minus, what is it, 2 times 8 times 5? Uh-oh, can I fit it there? Shrink it up a little more. Cosine 60. So that will give you QR. And what did you get for that, Alex? 7? Wow, that's a nice whole number. Okay, if you didn't want to do it law of cosines, that's okay. You could have found, especially since we're dealing with a 30, 60, 90 right here, what would this altitude length have to be? 4 square root 3. So at this point, if you didn't use this to find the area, you could do 5 times 4 root 3 divided by 2. And then once you have that, we also know, what's this length right here? 1. That length is 1. So we could do, another way to do this is we could do 1 squared plus 4 root 3 squared, Pythagorean theorem. And that still gives you 7. So it's another way to do it. Okay, now D. Find the other two angles of PQR. How are we going to find an angle here? Whoa, is that a yawn in the middle of that? Inverse, yeah, we could use inverse tan. If we want to find R, for instance, right here, we could do arctan of 4 root 3 over 1. So it's the arctan of opposite over adjacent. And Tom, what'd you get for that?
That was R, 81.8.
81.8 degrees. And then we could just subtract 180 minus your 81.8 minus your 60. So wait, hold on, this equaled R. And what about, so that gives you Q. What did you get for Q, Tom?
38.2.
38.2. Okay, questions? Okay, here it says to draw the unit circle and a first quadrant ray from the origin that makes angle theta with positive x-axis. And actually, I think it's a little big to fit here, so let's do that. There we go. So, I'm going to make a little crooked there. Okay, I'm going to make a first ray quadrant. So that just means that we start from the origin here. This has angle theta. First quadrant ray, not first ray quadrant. First quadrant ray. Now it says let point B be the point on the ray whose x-coordinate is 1. So we know that this is a unit circle. So this point right here is 1, 0. They actually call that A. So B with x-coordinate 1 would have to be directly above that here. That would have to be B. That point, that point would have to be 1 comma something. I don't know. And it says segment AB is tangent to the circle. So this is called tangent. Okay, I think we talked a little bit about this last year, but tangent to the circle means that you can, it just touches the edge of the circle. It also forms a right angle right here. In terms of theta, find its length. So how would I find this length? And we'll call it y because that y is the height right there. So how would we find that length in terms of theta? So tan theta equals what?
Y. Oh wait, it's actually y over 1.
It's y over 1
And then you do y.
because this is length 1. So tangent theta equals y. And there's your length. So why does it say there?
What's the bobble?
It wants to bobble you? Is that a word that you just made up?
What?
Bobble?
You can,
Boggle?
actually, you can. If you
Bottle.
make up words, you can use them if you love them.
So what you're saying is because you use a word that you made up because you loved it.
It sounds good.
I'm okay with it. Perfect. Well, that's fine with me. So I think what they're looking at here is that this is called a tangent, and it's probably called that because of the unit circle, and we have a tangent to actually determine that length of the segment. Okay? Pretty straightforward. Questions there?
I have a question.
Yes, Tom.
What if it is? What if it's a? Never mind.
Okay. Number 7, we have triangle PEA, has a 20-degree angle at P and a 120 at E. I'm going to try to make it somewhat realistic. 120. All right. Length EA is 6 inches. Shh, guys. All right, so we have that picture. What law are we going to use now? It says to find the lengths of the other two sides. Law of sines. So this is slightly different than the law of cosines, obviously, because it's called law of sines. But the reason we can use law of sines here is because we have this opposite angle to a side length. Okay, usually in law of cosines, we have a side angle side. But here the side's across from an angle. So because of that, we can do 6 over sine 20 equals x over sine 120. And x in this term, that is PA. That's this length right there. Okay? So we do that, we should just get, we could probably do it all at once. X equals 15.19. And that would be inches. All right. And then also, just if you're not sure how she did that, she just did 6, she cross-multiplied 6 sine 120 divided by sine 20. And that's PA. One thing I should say that I shouldn't say, if there's an issue here, most of the time it's an issue with not having your calculator in the right mode. If you have the calculator in radian mode, you're going to have a problem. So just make sure it's in degree mode and you're good. Now, question, can you find the other side using Pythagorean theorem? No, because it's not a right triangle. So we're kind of out of luck with that. We can do the exact same thing, but we don't have this angle right here. Oh, we just subtract. So that's 180 minus 140. So that'd be 40. And then we could do the exact same thing. So we could do sine. And again, it doesn't really matter which of these you have on top here. Some books do it this way. Others do it sine. So I'll just do it the other way to show it's possible. We could do sine 40 over, I'll put PE here, equals, and you can use either of the sides. You could do 120 over 15, sine 120 over 15.19, or sine 20 over 6. I keep the sine 20 over 6, just because if I messed up on that one, I'll still have it okay. So I will do sine 20 over 6. And then you'd have PE would equal, hold on, let me do that, just the math here. It would be 6 sine 40 over sine 20. And what'd you get, Jamie? 11.27 inches. And there are your other two sides.